So the next step is to take this code and use it, or the majority of it, to create a Streamlit app. You would go into streamlit.io. I logged in here, and I actually have the app itself. One way you can do this is to create a new app up here and use one of the templates. My recommendation, however, is to just follow along with my repository, which I'll share in the description. And just to show you how you can grab that repository, you would log into your GitHub account. This is my personal account. Once you're logged into your GitHub, you would then put in the URL for the Technovation water quality example. I've included this URL in the description of this video, so you can get it there. But what you would do then is go to the URL, and if I want to fork it, I can fork it, and it would now be in my personal account, and I can change the name if I want to. I can just say copy of Technovation water quality example, and then I'll create the fork. This is so that I have my own copy. And then if you click here, I can open it up in code spaces, create code spaces. So this will allow you to follow along with me in the tutorial, but looking at your own code and possibly even editing it yourself. You might not have some, in this case, some of the libraries installed. You can always go up here and do a new terminal and can start installing things that it's not finding. So Seaborn, and same thing here, scikit-learn. So you might have to go through and do some installation of libraries until you get the actual app to run. Okay, I've got it running here. So you should be able to follow along with me by forking the Technovation repository. I usually like to open it up in a different window. So it just asks you, and just so I can see it more fully. It is running. When you first open it, it builds the model. After that point, you don't have to. Let's go back, however, to the code, and we can see the way it works. I'm just going to move this over a bit. The document I'm editing is the Streamlit app.py. I've also had to upload my CSV file. I'm not going to open it because it's a very large file, but I uploaded that CSV file because that has to be accessible to be opened. So let's just kind of go through the code here and show you what I've done. So a lot of this should look familiar because I basically took it from and I've got it here, my Jupyter Notebook. And so all these are imported. I didn't cover this before, but this is the actual library that does the prediction. So it helped me create my model. This was the one that was recommended by Claude, and I ended up using. Here are my indicator thresholds again. That dictionary that has all the different indicators that they would test water with, and then what kind of threshold it was, and the moderate and high thresholds. I took my load and preprocessed data file, and on this side, I turned it into read data. However, it does the same thing. It reads the data and then converts the date to month, date, and year. My determined risk level, again, this is pretty much taken from my Jupyter Notebook. The one thing that I did was the debugging on the Jupyter Notebook side is a print statement. If you want to debug it here, it makes sense to have it print in my app itself. So you need this st.write, and that will print it out within the app. So I've got them commented out now, but for doing debugging and stuff, I could uncomment them and see them actually print out. So that's one thing as you're moving from Jupyter Notebook to Streamlit. Any print statements that you want to actually print, you'd want to have it do an st.write. But that's essentially the same function as over here in my Jupyter Notebook. The getRisk function takes the risk level of 2, 1, 0 and returns the word that goes with it. And this is for printing out the prediction at the end. This is building the model. So up here, a couple of things to note. This at st.cache data, what this does is every time you run the app, and especially when you're debugging, you'll be running it a lot. You don't want it to reload and reread in this Excel file. So what this does is it caches the data. So you put it above the function, and then it will just not rerun it every single time. Same with the building of the model. So this at cache st.cache resource will do the same thing. It will effectively run it the first time, but then once the model's been generated, it won't have to regenerate it each time. And this is also pretty much a copy of what I had over here for building my model, building my aggregated model data set. So I changed the names of the functions a little bit. You can see again, I've got a lot of debugging here that I've commented out. Again, these were just the printing out of the classification and the confusion matrix to tell us how accurate the model was. I did it already over in Jupyter Notebook, but I ran it here as well. However, I've commented it out at this point. So initially I printed it out just to make sure I was getting good response or good accuracy from my model, and I was satisfied with that, so I commented it out. This is my aggregate risk by date function, which is also taken from my Jupyter Notebook. I didn't have to really change too much other than the debugging statements. Then I had to write a function to predict the risk for a site. Basically, the way it works is here are all the different lakes or site. Some of these are the same lake, but at different, sites within the lake. Manipuri. So we've got different, 3 different sites on Lake Manipuri. You can choose a site and then choose a month and then run the prediction. I meant to choose a different lake. Let's try Emma. Okay, there we go. So that's moderate. I also put up a historical view just to give users a view of what the actual historical data on that particular site is. And again, this is the aggregated data over the many years that it's been monitored. That's how it works. So in here, let's go back to the code. So we give it the model, the aggregated data frame, the site that we're looking for, what month we're looking for, and the current year, which is, going to be whatever year you're in. In this case, it's 2025. So the reason I pulled this is when you're running a prediction, you have to give it all the columns in the data set. So the data set let me run this. Let me uncomment this because this will tell us what the columns are. So basically I had to make an input that would have all the columns except for the risk level. And so I'd feed that in and it would run it through the model to make a prediction. Right, so that's how predictions work. You feed everything from the data set that built the model except for the target column, and in our case, the target column is the risk levels. Let's run this again, just so I can give you so if I run the prediction, the model features. So the model features are the columns that I'm feeding into the predictor. So I have to supply it with that. So the site ID, the date which I generate is going to be, because I'm looking for February, I just said February 15th of 2025. And then I have to fill in these values. These columns are the features that were used to build the model. And I don't have that, right? I'm just making these up. So the recommendation again from Claude was to fill these in with a most recent piece of historical data because it would be similar to what we're looking for. So I took these in here and filled it in from historical data. I got the historical data and then I filled it in by copying it, and then I just changed the month and the year. Okay, so hopefully that makes a bit of sense. And so it would run it through and it would return the risk level. The predicted risk is model predict, and it would return that, which would give me a 0, 1, or 2. this is my function to create that heat map, aggregating for a calendar year. So now I'm going to aggregate by a date, not necessarily. The original aggregation was all the dates in my data set, and I was aggregating if there were multiple indicators for a particular date. In this case, I'm going to aggregate over the years. So I have a single calendar year, and then this would create the heat map that we see here based upon that. And again, I heavily relied on use of GenAI to help me create this function. So let's go down to the main body of our Streamlit app. So we write the title, the New Zealand Lakes Water Quality. I read in my data. I apply the risk level. So this is where I determine the risk level for a given row based upon multiple indicators, possibly. Then I aggregate the risk by date. So now I've got it all aggregated by different dates, and then I build my model. And here's where I'm going to set up my drop down here, which is all the different lakes that show up in the data set. It looks through the data set for unique sites and then puts them into a drop down box. So, or actually puts it into an array, which then I do set up as a sidebar select box with the sorted filtered sites. There are a bunch of sites in there that were numbers, and I just thought that wouldn't be useful for people to use. So I took only those that were strings but not digits. That's why we're taking out the digits here. Then I created an array of just the months of the year so that the user can choose a month. And the current year would be this year, whatever year we're looking at. And then this was setting up the risk color map for the heat map. And then if the user presses the run prediction button, it will do a predicted risk. And this is what which would come back with a 0, 1, or 2. And this is what turns it into the word high, moderate, or low risk. Safe is actually what I said. And then this is just to change the color to red, yellow, or green. This risk color map, which is up here. This was actually for the coloring of this word here. So is it going to be yellow, red, or green? That's what that was for. And that then allowed me to say, use my color to print out whatever the risk level was. And then I do my heat map, which shows the historical information from the data set. Otherwise, if the button's not being pressed, then it just prints out the instructions. And we can probably run another couple just so you can see safe. So that, as you can see, most of the historical data is safe. Let's find one that has mixed, like Dunstan. Let's try April. Safe. Okay, and you can see most of the historical data is safe for that. And now I can take this away, the model features, so I can go back to my model builder here. So my predictor, I'm not going to print that out anymore. So now if I go back and run it, rerun. Let me try to rerun it completely. And go back up. Close that. Okay, so now it's disappeared. Okay, so I had to actually really get that refreshing of it to get rid of that debugging statement. There you have it. So we have an app that can predict the risk level for a particular site. Definitely there's a possibility of going further with this. We could give more detailed information by a particular date. Next step might be to do something similar to what the Wawa site in New Zealand does itself, which is to display on a map. Now, they display on a map based on historical data or current data. So, what's the latest reading? We could potentially display something on a map based upon these predictions. Okay, so here's one way that you can take a data set and create a model and then turn it into an app for users along the lines of the SDG. In this case, we're looking at SDG 6, clean water. Go ahead and take this and see, what you could do as a next step to add to this particular app. Good luck.